Hey everyone, and welcome back. Today we're going to be doing a deep dive into something pretty cool. Something that I think we all see and use pretty often, but maybe don't think about too much.
Oh yeah, I know what you mean.
Natural magnets.
Huh. They are pretty amazing.
They are. And today we're going to try to uncover their origin story.
It sounds like fun. What are we looking at today to guide us?
So we've got this PDF here, all about natural magnets. Plus, we'll be pulling in some info from the Geology and Diamonds in the Sky podcast.
Oh, right. Yeah, I listened to that one. Lots
Yeah.
of good stuff about the early universe in there.
Exactly. It's actually super relevant here. So this PDF kicks off talking about these things called primordial blobs.
Primordial blobs.
Yeah, basically the idea is that like way back, like right after the Big Bang, the universe was so hot and dense that
Oh yeah, right. I remember this.
pure elements could like clump together.
Right. Like giant cosmic building blocks.
Yeah. Like imagine a massive blob of just pure iron or nickel.
Now that's interesting. Especially when we're talking about magnets.
Right. Because guess what makes up natural magnets?
Let's see. Iron, nickel, and cobalt.
Bingo. So picture this. These metallic blobs swirling around in the early universe.
And don't forget the intense magnetic fields back then. Crazy strong.
Oh yeah, for sure. So we got these blobs of pure ferromagnetic metal forming in this crazy intense magnetic field. What happens next?
Well, as the universe cooled and those blobs solidified, they would essentially become...
Zinc magnets.
Exactly. It's almost like the universe was making its own permanent magnets.
Billions of years before humans even came along to figure out how to do it.
Right. But it is kind of similar to how we make magnets today, just on a much grander scale.
That's what I was thinking. So the PDF goes on to say that these primordial magnets could actually be the source of the natural magnets we find on Earth today.
Oh, wow. Really?
Yeah, and they bring up meteorites as evidence.
Ah, meteorites. Always a good source of clues about the early solar system.
Right, so iron meteorites are thought to be fragments of these early magnets that broke apart and eventually crashed into Earth.
Like little time capsules from the early universe.
Exactly, and they've got those magnetic properties locked inside them.
Fascinating. So are all natural magnets from meteorites then?
Well, not exactly. The PDF also talks about these things called stony-iron meteorites,
Yeah.
specifically pallasites.
Pallasites. Those are the ones with the beautiful olivine crystals embedded in iron-nickel matrix, right?
You got it. And then there's these other meteorites called carbonaceous chondrites. They're some of the most primitive meteorites we've found, and they actually contain magnetite.
Magnetite, you say. That's a pretty clear sign that magnetism was at play very early on.
Right. So we've got all this evidence of ancient magnetism in meteorites. But how does that tie back to the natural magnets we find here on Earth, like lodestone? Not all natural magnets are from meteorites, right?
You're right. Most of the naturally magnetic rocks found on Earth aren't from meteorites. But think about it. Earth formed from a giant cloud of dust and gas, right?
Oh yeah, back to the early solar system we go.
Well, those primordial blobs we were talking about earlier were likely part of that cloud.
So as Earth solidified.
Those already magnetized chunks became part of its structure.
That makes sense.
It's really a fascinating connection. It's kind of amazing when you think about it.
What's that?
The way both natural and man-made magnets actually work, they both rely on the same basic principle.
Oh yeah. Fill me in.
It all comes down to these things called magnetic domains.
Magnetic domains. Okay.
Yeah.
I think I've heard those, but maybe a little refresher would be helpful.
Sure. So basically, you've got a material like iron, right? Inside that material, you have these tiny little regions, and we call them magnetic domains. They're like microscopic magnets, each with their own north and south pole.
Huh, interesting.
But here's the thing. In a regular piece of iron that's not magnetic, those domains are all jumbled up.
Pointing in random directions.
Exactly. So their magnetic fields kind of cancel each other out, and the overall piece of iron isn't magnetic.
Okay, so how do we get it to be magnetic then?
Well, we need to get all those domains pointing the same direction.
Make them line up.
Right. And we can do that with heat and a strong magnetic field.
So you heat up the iron, put it in a magnetic field, and boom, all the domains fall in line.
Pretty much. As it cools, the domains get locked into that position, and you've got yourself a permanent magnet.
So is that what happened with those primordial blobs way back in the early universe?
That's the idea. All that intense heat and those crazy strong magnetic fields would have aligned the domains within the blobs.
And created these massive ancient magnets.
Exactly. And then eventually pieces of those magnets ended up here on Earth as meteorites.
Or became part of the Earth itself. Wow. So we've got these ancient cosmic magnets embedded in our planet. It's wild to think that something as simple as a magnet has such a deep connection to the universe's history.
I know, right? And there's still so much we don't know. It makes you wonder what other secrets these magnets might be holding.
Oh, for sure. And if those primordial magnets are still out there in space, could we actually detect them somehow?
That's actually something scientists are working on right now. They're using telescopes and all sorts of other instruments to try and detect those ancient magnetic fields.
And if they find them, it would be huge, right?
Absolutely. It would be more evidence to support this whole theory. Plus, it could open up all kinds of new research possibilities.
So we may not have all the answers yet, but we're definitely getting closer to understanding the origin of natural magnets.
Yeah, it's a pretty incredible story when you think about it. We're talking about these tiny little magnets connecting all the way back to the Big Bang.
To the very beginning of the universe.
Amazing, right?
I know, it really makes you think, like we have these magnets on our fridge, right? But they could be connected to these giant ancient magnets out there in space.
It's mind-blowing when you really stop and consider it.
It really is. So much bigger than ourselves.
Definitely. It reminds us how much we still have to learn about the universe.
Right. Like this theory about the primordial magnets. It's just one example of how we're constantly making these new discoveries and connections.
And finding these hidden links between things that seem totally unrelated.
It makes you wonder what else is out there waiting to be discovered.
Exactly. And it all comes back to that sense of wonder and curiosity.
For sure. Like, I'm never going to look at a magnet the same way again.
Me neither. Think about it the next time you see one. That little magnet on your fridge could have come from a giant primordial blob formed billions of years ago.
Wow, yeah. It's almost humbling. Like, we're not just watching the universe unfold. We're part of it.
That's a great way to put it. We're all made of the same stuff.
Star stuff, right?
Exactly. And this whole idea of magnetic domains and how they work, it just shows you the power of scientific inquiry.
Yeah. By asking questions and exploring, we can unlock all these amazing secrets about the universe.
Absolutely. It's a journey that never really ends.
Well said. Well, I think that about wraps up our deep dive into natural magnets for today.
Yeah, we've covered a lot of ground.
From those primordial blobs to meteorites to how we make magnets today, and even touched on what might still be out there in space waiting to be discovered.
It's been a fascinating journey.
It really has. And hopefully it sparks some curiosity in all of you listening.
Yeah, the next time you see a magnet, take a moment to think about its amazing origin story.
And who knows, maybe one of you listening will be the one to make the next big discovery in this field.
Keep those minds curious, everyone.
Until next time.